Snakes have haunted human nightmares for millennia, but the truth about their origins is far more terrifying than any ancient myth. These legless predators didn't always slither through our world as they do today. Scientists have long debated how these creatures evolved from their limbed ancestors, and recent fossil discoveries have revealed a prehistoric world where serpents grew to unimaginable sizes and possessed abilities that would make modern pythons seem like harmless garden worms. After all, it's nearly impossible to prove with certainty that we fully understand the complete evolutionary journey of these mysterious reptiles, especially when new fossil evidence continues to emerge from remote locations around the globe. The story of snake evolution begins in a world so different from ours that it challenges everything we thought we knew about these predators. From ancient serpents with functional legs to prehistoric giants that could swallow crocodiles whole, the fossil record reveals creatures that blur the line between scientific reality and mythological terror. Indigenous peoples across every continent have spoken of great serpents that once ruled their lands, and perhaps their ancestral memories contain fragments of truth about encounters with these ancient monsters. Moving to the swamps of prehistoric Colombia, we encounter our first terrifying ancestor. Titanoboa cerrejonensis, discovered in the coal mines of Cerrejón, represents the largest snake that ever lived. This prehistoric monster measured an astounding 42 feet in length and weighed over 2,500 pounds, making modern anacondas look like mere earthworms by comparison. Scientists estimate that Titanoboa lived approximately 60 million years ago, shortly after the extinction of the dinosaurs, in a world where temperatures soared 10 degrees higher than today. The sheer size of Titanoboa suggests that ancient Earth's climate could support reptilian giants we can barely imagine today. Paleontologists believe that these massive serpents survived because the post-dinosaur world offered abundant large prey and optimal tropical conditions. The Cerrejón Formation's perfect preservation conditions have revealed not just one specimen, but evidence of an entire ecosystem dominated by these colossal predators. Local Colombian tribes have long spoken of La Gran Serpiente in their oral traditions, describing massive snakes that could swallow entire canoes, stories that modern scientists now recognize might contain echoes of ancient encounters. Recent expeditions to the Cerrejón mines have uncovered vertebrae so large that researchers initially mistook them for crocodile remains. The discovery team, led by paleontologist Carlos Jaramillo, found evidence suggesting these giants were ambush predators that lurked in ancient river systems. Expert analysis indicates that Titanoboa possessed crushing power exceeding 400 pounds per square inch, enough to pulverize the bones of prehistoric crocodiles and giant turtles. Maybe Titanoboa really is extinct, lost to changing climates and shrinking prey. Or maybe its descendants still lurk in the unexplored depths of South American rivers, waiting for the right conditions to reveal themselves once again. Our journey through snake evolution takes us next to the Middle East, where fossils of Najash rionegrina challenge everything we thought we knew about early serpent anatomy. Discovered in Argentina's Rio Negro province, this 90-million-year-old fossil represents one of the most complete early snake specimens ever found, measuring approximately 6 feet in length with fully functional hind limbs. Scientists have determined that Najash possessed a sacrum, pelvic girdle, and well-developed legs with ankles and functional feet, proving that early snakes were far from the limbless creatures we know today. The discovery of Najash revolutionized our understanding of snake evolution, providing the missing link between lizards and modern serpents. Paleontologist Sebastián Aposteguia's research team found that these ancient snakes retained their limbs for millions of years after developing the flexible skull and elongated body plan characteristic of modern serpents. The fossil evidence suggests that leg loss occurred gradually, with different lineages losing limbs at different rates depending on their ecological niches. Indigenous Patagonian peoples have traditions describing serpientes con patas, or snakes with feet. Stories that European colonizers dismissed as mythology, but that now appear remarkably accurate. Modern evolutionary biologists studying Najash have identified specific genetic mechanisms that controlled limb development in early snakes. Research indicates that mutations in the Hox genes gradually eliminated hind limb formation over millions of years, but the process was far from uniform across different snake lineages. Some species retained vestigial limbs for tens of millions of years, creating creatures that would appear utterly alien to modern observers. Maybe these transitional forms truly vanished with changing environments. Or maybe in the remote caves and unexplored regions of Patagonia, descendants of these limbed serpents still survive, hidden from scientific discovery. The evolution of snake anatomy becomes even more mysterious when we examine Sanaja indicus, a prehistoric serpent discovered coiled around dinosaur eggs in India's Lametta Formation. This remarkable 67-million-year-old fossil provides unprecedented insight into the feeding behavior and ecological relationships of Cretaceous snakes. Measuring approximately 11 feet in length, Sanaja represents a transitional form between primitive snakes and their modern descendants, possessing features that allowed it to prey on newly hatched sauropod dinosaurs. The discovery team, working in the Gujarat region, found Sanaja preserved in the exact moment of predation, with its coils wrapped around a sauropod nest containing eggs and a recently hatched baby dinosaur. This extraordinary fossil provides direct evidence that prehistoric snakes were already accomplished egg thieves and infant predators 67 million years ago. Scientists believe that Sanaja's relatively primitive jaw structure required it to target young, soft-bodied prey, rather than the massive adult dinosaurs that dominated its environment. Local Indian communities in Gujarat have ancestral stories of Naga serpents that could steal the children of great beasts, tales that align remarkably with the fossil evidence. Research into Sanaja's anatomy reveals that early snakes possessed more rigid skull structures than their modern relatives, limiting their ability to consume large prey. The evolutionary development of the kinetic skull, which allows modern snakes to unhinge their jaws and swallow prey much larger than their head, occurred gradually over millions of years. Paleontologists studying Indo-Pakistani fossil sites continue to find evidence of diverse snake lineages that experimented with different feeding strategies during the age of dinosaurs. Maybe these ancient specialists disappeared with their dinosaur prey 66 million years ago. Or maybe in the unexplored caves of the Western Ghats, descendants of these prehistoric predators still follow ancient hunting patterns, waiting for the right moment to reveal their presence. Moving to Australia's prehistoric past, we encounter Wanambi narracortensis, a massive, non-venomous serpent that survived until just 40,000 years ago, making it one of the most recently extinct giant snakes. Discovered in the Narracorte caves of South Australia, Wanambi measured up to 20 feet in length and weighed an estimated 110 pounds, representing the last of the Matsoidae family that once dominated southern hemisphere ecosystems. Scientists believe that Wanambi was a powerful constrictor that preyed on the megafauna that populated Pleistocene Australia. The extinction of Wanambi coincides suspiciously with the arrival of humans in Australia, leading researchers to investigate whether early Aboriginal peoples encountered these massive serpents. Paleontologist John Scanlon's research indicates that Wanambi possessed unique vertebral structures that allowed it to achieve sizes impossible for modern Australian snakes. The Narracorte fossil deposits have yielded complete skeletal remains, showing that these serpents were apex predators in their ecosystem, competing with giant monitor lizards and marsupial predators for large prey. Aboriginal Dreamtime stories from the region describe waggle or rainbow serpents of enormous size that shaped the landscape and controlled water sources. Recent analysis of Wanambi fossils has revealed that these snakes possessed heat-sensing capabilities, similar to modern pythons, allowing them to hunt effectively in Australia's diverse climates. Research teams working in the Narracorte caves continue to find evidence that Wanambi populations persisted longer than previously thought, with some specimens dating to just 25,000 years ago. The discovery of campfire remains and stone tools in the same geological layers suggests that early humans definitely encountered these giants. Maybe Wanambi truly vanished with the changing climate and human hunting pressure of the late Pleistocene. Or maybe in the vast, unexplored cave systems beneath the Australian outback, populations of these ancient giants still survive, hidden in the darkness where they once ruled. The most mysterious chapter in snake evolution involves the development of venom, a biochemical innovation that transformed serpents from simple constrictors into sophisticated chemical warriors. Fossil evidence from China's Jehol Formation has revealed Parvoraptor estesi, a 125 million year old snake that possessed primitive venom delivery systems, making it one of the earliest known venomous reptiles. This discovery suggests that venom evolution occurred much earlier in snake history than previously believed, fundamentally changing our understanding of serpent biochemistry. Scientists studying venom evolution have identified that early snake toxins were relatively simple proteins that gradually evolved into the complex cocktails of enzymes, neurotoxins, and hemotoxins found in modern venomous species. The fossil record indicates that venom systems evolved independently multiple times in different snake lineages, creating a diversity of toxic delivery methods that rivals any pharmaceutical laboratory. Research into ancient venom proteins has revealed that some prehistoric toxins were far more potent than anything produced by modern snakes, capable of killing prey many times larger than the serpent itself. Indigenous peoples across Asia have preserved stories of serpent spirits with poison so deadly that it could kill with a single drop, descriptions that align with paleotoxicological reconstructions of ancient venom systems. Modern biochemical analysis of fossilized venom glands from Chinese specimens has revealed protein structures unlike anything found in contemporary snakes, suggesting that prehistoric serpents possessed biochemical weapons that evolution has since abandoned. Research teams continue to discover new venomous snake lineages in China's fossil deposits, each revealing unique approaches to chemical predation. Maybe these ancient venom systems truly disappeared with their creators millions of years ago. Or maybe in the remote mountains of Asia, descendants of these prehistoric chemical warriors still carry the genetic blueprints for toxins beyond our current understanding. The terrifying truth about snake evolution is that we've only glimpsed fragments of their complete story. From leg-bearing ancestors to colossal constrictors, from dinosaur hunters to chemical assassins, serpents have experimented with body plans and predatory strategies that challenge our understanding of reptilian biology. Each fossil discovery reveals new mysteries about these ancient predators, and perhaps the most frightening realization is that the snakes we fear today represent only a pale shadow of the monsters that once dominated our planet. The next time you encounter a snake, remember that you're looking at the descendant of creatures so terrifying that they would make our worst nightmares seem tame by comparison.